In one way, focusing in on a specific application, but on the other hand, we're going to be blowing that up to have the broadest implications possible. So joining me now to talk about the internet computer and blockchain singularity, and the ways that these can help make the internet and compute more equitable, perhaps. Please give it up for the founder and chief scientist at Definity, Dominic Williams. Thank you. Thank you very much indeed for joining us. Terrific conversation. Obviously, you heard that. We were listening to it backstage there, and I think there's going to be a lot of the pillars maybe that Winston was talking about that we're going to be touching on in our conversation. The first thing I'd like to do, though, is to take a step back, because we're talking about Web3, a new generation of compute and computing in a way. But I'd like to know how we got there. So could you start us off, perhaps, by telling us about our journey to Web3 through Web 1, maybe Web 2, and I know you've been involved in all of these stages one way or another, to the point where we're at and we're looking at this next generation?
Sure. So, you know, Web3 is a very exciting new phase of the internet, but it's enabled by new technology. Mm-hmm. And at the Definity Foundation, we work on this thing called the internet computer. And it will power a lot of these kind of transformative changes that are coming with Web3. And the internet computer is conceived as an extension of the public internet that enables the internet not just to connect everybody, but also to provide a compute platform. So back in the 1990s, there was a big debate about whether people would want to connect via America Online, CompuServe. Yep. Microsoft had this idea about the information superhighway, and you know, the marketing was that everybody would be put in a kind of walled garden. Yes. By corporations where it'd be very safe and the content would be curated for them. But in the end, everybody wanted to connect via the public internet, which was free and permissionless, and created a fantastic free market where you could create a website without permission, and a competitor couldn't apply to the owner of the internet to have your website slowed down, for example. So, you know, today, people build using traditional technology on platforms like Amazon Web Services, Google Cloud, Microsoft Azure, and so on. And these are private platforms run by big tech corporations generally. And you build using traditional technology components like databases, web servers, middleware, and so on and so forth. And the internet computer provides a completely different way of building absolutely anything, where you can just write a new kind of code and upload it to the internet where it runs on a public network. And in the same way that the internet provided capabilities that you couldn't get from America Online and CompuServe and so on, yeah. The internet computer provides people building on the internet computer with a completely new set of capabilities.
So the way that I look at that, Web 1, very, very simplified, and you may disagree, but Web 1 was very much someone's going to publish something, and you read it, and you can click through and find other resources that are connected to it. Web 2 is where all of a sudden we can start as consumers to make our own content. Well, this sounds great, but there's still big tech at the middle of it. I'm creating content, whether it's through micro-blogging platforms or through video uploading platforms or whatever, but I'm not seeing a great deal of benefit from that. It's still some big tech behemoths in the middle of it. There's still a lot of this centralization, and that's Web 2. But Web 3, that's an opportunity where actually there isn't the big tech hubs right in the middle of it. It's me as a stakeholder in the internet, in the web. Actually, I have a degree of control, a degree of say. I'm not at the behest. I'm not beholden by a handful of big tech platforms. Does that kind of also fit into the journey and the narrative here when we start talking about a distributed computer?
Well, the internet computer can be thought of as a world computer, as a kind of everything computer. And when you build on this everything computer, you're building with a new kind of code. And that code is tamper-proof, so you don't need a firewall to protect it, for example. It can't be encrypted by ransomware. It's unstoppable. And it can also, if you wish, be made autonomous. Now, if you're an enterprise, there are already some banks, for example, tentatively building, and some government initiatives tentatively building on the internet computer now. And for these enterprises, the proposition is slightly different. They don't want to be captive customers of big tech, and they want to build systems that can't be hacked and that are more robust or unstoppable. But for people in Web3 who are really trying to reinvent the services that we use every day, they're looking at reinventing ownership. And of course, everyone hears about things like NFTs, but these are really just simple manifestations of the grander Web3 trend. So, a fully realized an example of a Web3 service would be something like a social network that runs on the internet computer that doesn't have a human controller or doesn't have a company behind it, and is run by a very sophisticated DAO, a thing called a decentralized autonomous organization. Yep. That's called a service nervous system that can completely controls the service. It acts both as a digital democracy with many stakeholders, but also as a system that allows that social network running on the internet computer to be updated in a fully automated way, such that there's no human beings, not developers, not companies, no board of directors, no CEO, and that the service runs, we might call it an open internet service, runs approximately analogously in some sense to an open source software project. But of course, running a social network or any other service in that kind of manner is much more complicated. And the users of these services will become part of the community in a new way. They'll become owners of the service in the sense they hold governance tokens. They'll become part of the team because they'll help with tasks like content moderation.
Yep.
And essentially these services are going to make their users founders. And very quickly they're going to amass enormous decentralized teams all around the world of millions of users. And that's how Web3 is going to break the network effects of Web2. And it's just beginning to happen now, and it's going to be very exciting.
Okay, so there's a lot there to unpack, and you went on to DAOs already, and we will come back to that again in a moment, and maybe some of the lessons learned from earlier applications of this. But you talk about reinventing apps and services, but running on this platform. Is this what you mean by this term, the blockchain singularity? Is this ability for this world computer, the internet computer, to run a reimagined, if not reimagined, a re-architected version of apps and services that we already use every day, but without this centralization?
Yeah, so the blockchain space is very confusing. And it's confusing partly because there are these huge financial incentives involved that people promoting this blockchain or that blockchain want to sell you their tokens. And so there isn't really the free flow of information. Mm-hmm. And there are a lot of misconceptions. So oftentimes you'll hear that some kind of Web3 service is built on blockchain XYZ. But if you dig a bit further, you'll find that the service is really running on Amazon Web Services, and it's just keeping a few tokens or NFTs on the blockchain. And then if you dig further still, you'll find that the blockchain runs on the cloud. Amazon Web Services, Google Cloud, Hetzner, and so on. So, and of course, those kind of blockchains, the smart contract code can't serve web. It's isolated, it can't serve much data, it can't do much data processing, it needs the help of the cloud. The internet computer is a very different thing. The internet computer is created by a sovereign network of these things called node machines, a bit like the internet's created from routing devices, which are run by and owned by independent parties. And the smart contracts that it run are very, very efficient. I mean, it's designed to ultimately enable people to build systems that run more efficiently than the systems on, legacy traditional tech like Amazon Web Services. So a very different thing, an increase in efficiency of tens of thousands of times. The code can serve web, it can reach out of the blockchain environment, to the point that it's better to think of it not as a blockchain, but as a world computer, as an everything computer, as the internet computer. And that really makes it possible to do completely new things. And when when the project talks about blockchain singularity, what it means is that people are going to start building entirely on the internet computer. And they won't need traditional tech like cloud services or databases. And everything, and everything from enterprise systems through financial systems to, metaverse, social media, games, you name it, will be built on the internet itself rather than on traditional legacy tech.
Okay, so a couple of things there. What have you got against the cloud? Because you've mentioned it a couple of times there. You've called out Amazon Web Services and the fact that some other networks are, may claim to be one thing, but actually are just running on the cloud somewhere. We spent the last 15 years, certainly in enterprise IT, talking about moving from on-premise systems, from data centers, moving into the cloud. And now you're saying, or are you, that actually this cloud probably isn't where the next generation of technology might best be placed?
Well, that's right. So, look, I mean, first of all, moving enterprise systems out of your, homegrown data center onto the cloud is a very good...
Out of the basement, basically.
Yeah, it's a very good idea. And, the cloud has brought enormous advantages to entrepreneurs, for example, who, by reducing startup costs.
Yep.
Like back in the dot-com era, it was extremely expensive to create something like a social media service and scale it with demand. And I myself, many years ago spent time, excuse me, inside data centers, installing new blade servers, trying to scale up capacity.
Been there, done that.
And it's obviously much more convenient to just build something on the cloud and make use of capacity that's already provisioned for you.
Instant capacity, click, it's provisioned. All of a sudden,
brilliant.
Stephen Fry retweets my service, and it will scale instantly.
Yes, I'm a great supporter of the cloud. It's brought about enormous efficiencies, and it's made it much easier for startup entrepreneurs to scale out systems, and that's something that's dear to my heart.
Yeah.
But we're not talking about changing that with the internet computer. The internet computer can be thought of as a kind of crypto cloud, if you like, in the sense that you can use it in the same way. It's like a serverless cloud. You can just write this code, upload it to the internet, it runs there. So you get many of the same advantages. But the difference is, firstly, that you're not building on a proprietary infrastructure. You're not going to become a captive customer. It's like the difference between using AOL and the internet. You're building on a free public network. And not only that, but when you build on the internet computer, you're building on something that's created from a protocol that leverages advanced mathematics to create different properties. So for example, your code is tamper-proof. So, all of this started long ago now, back in 2008 with Bitcoin. And, you don't need a firewall to protect a Bitcoin, right? If you own Bitcoin, you can control it with a key. There's no firewall protecting your Bitcoin. When you interact or you build something with smart contracts on Ethereum, again, those smart contracts which store data and process data don't need a firewall to protect them. And in exactly the same way, When you build something much more complicated, like a large-scale enterprise system or a social network on the internet computer, or indeed something much more simple, you don't need a firewall to protect it from hackers. It can't be encrypted with ransomware. The code's unstoppable. There are lots of other great things too. The code is greatly simplified compared with the traditional IT that you'd run on the cloud.
Yeah.
And in addition to all of those advantages, you can, if you're in the business of Web3, you can build a completely new kind of open internet service that runs under the complete control of a community and doesn't, isn't exposed to the individual decisions of any one person or company, or there's no need for a board of directors and a CEO. And this actually provides the groundwork for some very exciting new business models for entrepreneurs.
And I do want to come on to those in a moment. I really, really do, and want to hear about how you operate at Dfinity as well. But I just want to come back and maybe address some of the questions that probably in the mind of our audience, certainly in my mind. One of the criticisms about existing blockchain-based networks at the moment, for example, is speed, or more particularly lack of speed. And that certainly seems to be a hindrance when competing against traditional financial transaction-based networks. So what is it that makes the Internet Computer Network not only fast enough, but really, fast enough to be able to handle the volume of compute that you see a worldwide computer would need to be able to handle?
Well, there are three main challenges in designing a network like the Internet Computer. Number one, as you mentioned, is speed.
Yep.
Number two is throughput. What's the total volume of transactions you can process, and what's the total amount of data that you can store? And number three is cost. What's the efficiency?
Yes.
Blockchains generally have made great strides. I mean, the modern proof-of-stake blockchains have made great strides with speed. Where they tend to fall down is throughput and efficiency, and also with key capabilities like serving web. The Internet Computer is the only blockchain in existence where smart contract code can serve web. And there are various other technical challenges too. So with respect to the Internet Computer specifically and speed, there are a number of innovations. So when you run a transaction that can update data, say for example you're using a social network and you make a post, it will commit that post that you made in a second. Around about a second, which is pretty quick. I mean, most people, if they press, imagine you're on Reddit and you press post, one and done. That's fine. Now, of course, you have to be much faster than that when you're serving content into a web browser, because users want to see stuff appear straight away. So the way the blockchain handles that is it pre-finalizes transactions. It's called a query call. So, for example, if somebody is creating a system on the Internet Computer and they want to serve, the HTML, JavaScript, CSS, snippets of data into the page in response to JavaScript requests and so on and so forth, that content is typically what's known as pre-finalized, which means that it's kind of signed by the blockchain ahead of time, so that the Internet Computer can serve it in milliseconds. With respect to throughput, behind the scenes, the Internet Computer is composed of subnets. Subnets are formed from node machines, from independent node providers that are combined by the governance system of the Internet Computer, using something called chain key cryptography, and that also makes it possible to weave all of those subnets together into a single blockchain, the Internet Computer, which is thus horizontally scalable. So whenever it needs more capacity, it can just add more subnets. These subnets, if they're overloaded, can split into two subnets and things like that. It's a pretty sophisticated system. And with respect to efficiency, I mean, it's tens of thousands of times more efficient than what you'd consider a traditional blockchain. And it's in the same ballpark as traditional IT, and over time it'll be, I believe, significantly more efficient. Yeah.
Okay, yeah, I'm pleased you beat me to the efficiency point. And then my other question before we start moving on to the disruption in terms of governance, and we'll come on to DAOs as part of that, is the nodes. Who owns these nodes at the moment? So Internet Computer's already out there. Who is it then who is currently the custodian of these nodes? Is it people like you and me? Are they corporations somewhere? Who is it?
So you or I could run a node. They're called node machines. They resemble something like a Blade server, but they have a standard specification, and there's no redundancy within the machine to reduce costs because the network has redundancy. So there's you only have one power supply in these things and so on, and there's no RAID for the storage, if that makes sense. And you can either build one of these machines to the spec, or you can buy them from people who'll build them for you. And then you have to install them in a data center. In principle, you could do it from home. But the Internet Computer creates subnets by combining node machines that have different owners. They're in different data centers. They're in diverse geographies, and have a variety of jurisdictions. Like you wouldn't want all the nodes in a subnet in the EU, for example. So the way that the Internet Computer forms these subnets limits how many node machines an individual node provider could run. And so if you want to be a node provider and maximize the number of nodes, you want to install them in different data centers around the world and so on.
So you've got a lot of diversity there in terms of the ownership, in terms of the geography, in terms of the roles of those node machines. But what's running all of this? What is it? Is there still a central brain, if you like, that is divvying out everything here?
Yeah, so this is where, it can get a bit mind-bending for people who aren't used to it in the same way I remember the internet was, back in the 90s. The Internet Computer isn't run by an organization. It's run by a thing called the network nervous system, which you can think of again as a kind of DAO, but it's something more sophisticated. Essentially, it's a kind of digital democracy. The reason it's called a nervous system is people stake these governance tokens called ICP to create neurons. These vote on proposals, but you can make them vote automatically by configuring them to follow other neurons. It's a very effective system. The Internet Computer Network will soon have been running for 2 years. It's been under development for really since 2015. But since it's been running, I think it's only had a few seconds downtime, and the network has self-updated hundreds of times at this stage. So people are constantly proposing technical improvements, and these are submitted oftentimes in the form of code. And when the brain of the network nervous system, adopts them, it actually applies these to the node machines. So the node machines follow the instruction of the brain, if you like, and they upgrade the software, the network software that they run, and therefore upgrade the mathematical protocols, network protocols, that they use to interact with each other and create the Internet Computer. So for example, these node machines are listening to the brain, and it will instruct them, for example, to combine to create a new subnet to add more capacity to the Internet Computer, this everything computer, because more people are building on it and it needs more capacity for compute and storing data. So that's one of the great innovations. If you look at the Internet itself, the Internet is, mostly decentralized, which is a very good thing. But actually, ICANN, which is an American not-for-profit organization, still plays some pretty fundamental roles, and there are some issues and problems that derive from that. If you look at domain names, for example, ultimately, if you have a domain name, in principle, the registrar of the top-level domain can delete that domain name, and the ICANN can even change the registrar that's responsible for a top-level domain name. So, that's something that's not desirable. The Internet Computer doesn't have an organization running it. Instead, it has this thing called the network nervous system, which is open and permissionless. Anybody can submit proposals to it. Anyone can participate in the governance of the Internet Computer. And so in that sense, it's an advance from the Internet, the way the Internet itself works, which, of course, is not surprising because it's, coming along 30 years later. Yeah.
Okay, we've got 5 minutes left, and I've got 3 questions that I want to try and fit into that time. The first one of those is, very quickly, just tell me where it is and what kind of applications are already running on Internet Computer. Secondly is about Dfinity, your role at Dfinity, and where Dfinity fits into the Internet Computer. And then finally, how people here, if we've piqued their interest, can best engage with Internet Computer, maybe look at how to experiment building an application for that. Can we do that in 5 minutes?
Sure, sure.
Okay.
I mean, so first of all, I won't cover, I mean, enterprise adoption is just coming now, so we've got some sort of governments, banks, all kinds of partners tentatively building things on the Internet Computer. They're just wanting to build because they don't want to be a captive customer of the clouds, and they want to be able to build without firewalls, and they want to be able to build secure systems that are much more robust, and then have some other properties. But if you're an entrepreneur, for example, and you're interested in Web3, take some time, look at the sample apps, see how easy it is to build on the Internet Computer, and then look into this thing, another acronym, I'm afraid, and another thing called the SNS, which stands for Service Nervous System, which is a new technology that's derived from the network nervous system, the NNS, just rolling out now. And this is an integral part of building the next generation of Web3 services. So you create something, for example, I think the first service using this technology is called OpenChat.
Yes.
Yeah, and it's a chat service, a messaging service that runs on the Internet Computer. It's a little bit different to something like WhatsApp, right?
I was going to say, is it a WhatsApp for Web3?
Well, you get the same functionality, albeit it tends to have more group chats on it with thousands of people in them because, there's people in the Web3 community use these group chats quite heavily. And what's interesting is, although it's got the same functionality, albeit it's more optimized for these group chats, a bit like Telegram, is that your account on this messaging service is like a crypto wallet. And you're going to be able to send like tokens, Bitcoin, NFTs with chat messages, which I think illustrates the ways that something like this, because it runs 100% on the blockchain, illustrates the ways Web3 services like this can provide new functionality. Now, the next big thing is a proposal's just gone into the network nervous system a few days ago from the developers that say that they want the network nervous system to take over, if you like, this chat service, create a service nervous system governance DAO, and assign control of OpenChat to this governance DAO. At that point, only the governance DAO will be able to push updates to OpenChat. And there'll be something called a decentralization sale to distribute governance tokens in this governance system to whoever's interested. The proceeds of that, it's not an ICO, the proceeds of that swap event will continue to be maintained in the treasury of the governance system itself. So you've got this, there'll be this incredible service that has no owner. It's owned, if you like, by its governance system, which has its own, by a decentralized autonomous organization. Of course, the founders will get governance tokens in too. And this thing's going to grow by distributing governance tokens to users who help with referring other users, help with tasks like content moderation. It's going to be making, I think, in the next few years, millions of users into founders. And this is a fundamental innovation obviously in the way that, things like social networks can run. That will prove very revolutionary because ultimately, we're kind of replacing the role of, governmental organizational structures like companies and partnerships and trusts and funds with these entirely digital governance systems. And for entrepreneurs, it's a new way to grow, to take on the might and the established network effects of Web 2 services, and to get rid of the bureaucracy involved with traditional company building, new ways of raising money from anywhere in the world, new ways of growing, and to create something that has a competitive chance. Like, there's no other way of producing a chat service that can take on the likes of Snapchat and WhatsApp, right? You need to go Web 3. And, right now, this stuff's gearing up into motion, and there's all these interesting things being created. And if anyone's an entrepreneur wanting to build things on the internet, this is the direction they should head. And you go fast forward 5 years from now, 10 years from now, certainly, the vast majority of startups won't be have startup companies necessarily behind them. There'll be DAOs. There'll be community DAOs.
And that's what I find so fascinating about this conversation, is that obviously there's a technology disruption here, but then there's a whole corporate governance disruption conversation as well, and it really fuses the two of those together. Dominic, thank you so much for sharing that with us today. Please show your appreciation for Dominic from Definity. Lots more conversations to be had on that, and I have a feeling that before 4 years from now is out, we'll be talking about this again. But for now, one more time, please give it up for Dominic Williams.
Thanks.
Thank you very much.